Hello, let's evaluate this gamma function relation summation n equal to 1 to infinity gamma of n plus ky gamma of n plus 2k plus 1 is gamma of ky gamma of 1 plus 2k, right? So let's try to solve. Summation n equal to 1 to infinity gamma of n plus ky gamma of n plus 2k plus 1. Here let's multiply and divide with gamma of k plus 1 into gamma of k plus 1, right? So bring this summation is for n, right? So let's bring this outside of this summation, which is 1 by gamma of k plus 1 summation n equal to 1 to infinity gamma of n plus k gamma of k plus 1 by gamma of n plus 2k plus 1. Now you might have understood why we have multiplied gamma of k plus 1 and gamma of k plus 1. How does it look like? This looks like a beta function, right? I mean, let's write it down. Beta function of m comma n is gamma of n by gamma of m plus n, right? I mean, you can write it in the integral form. Beta of m comma n is integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx. So our function, this function, so write it down here. So our function can be written as 1 by gamma of k plus 1 summation n equal to 1 to infinity. This is beta of n plus k and k plus 1, right? It can be written as integral 0 to 1, right? How will you write this? X power n plus k minus 1, right? 1 minus x whole power k plus 1 minus 1, which is k, right? Dx. Let's do one thing. 1 by gamma of k plus 1, right? And integral 0 to 1. As you can see, the summation is only for n, right? Separate the n part from x part, which is x power n plus k 1 minus x whole power k summation n equal to 1 to infinity x power n. Sorry. This part is, if you are substituting n, it will be k minus 1, right? It is, then it will be x power n dx. So how will you calculate this? Summation n equal to 1 to infinity x power n is x plus x square plus x cube plus and so on. It is geometric series which can whose summation is a by 1 minus rx. A is first term, x by common ratio is x, which can be written as x into 1 minus x whole power minus 1. So substitute it 1 by gamma of k plus 1 integral 0 to 1 x power k minus 1 1 minus x whole power k. This will be x into 1 minus x whole power minus 1 dx, right? Let's simplify this. That is 1 by gamma of k plus 1 into x power k minus 1 into x, right, which is x power k. Similarly here it is 1 minus x whole power k minus 1 dx, right? This looks like a beta function again, right? This can be written as Let's write it down again so that you can understand easily. Is x power k can be written as k plus 1 minus 1. So this can be written as 1 by gamma of k plus 1. This will be beta function of this will be k plus 1, right? Then this is k. That is 1 by gamma of k plus 1. Beta function of mn is beta of m into beta of n by beta of m plus n, right? That is here gamma of k plus 1 into gamma of k by gamma of k plus 1 plus k, which is 1 plus 2k. Fine. This gamma of k plus 1, this gamma of k plus 1 will go off. Then gamma of k by gamma of 1 plus 2k is the solution. So final result is summation n equal to 1 to infinity gamma of n plus k by gamma of n plus 2k plus 1 equal to gamma of k by gamma of 1 plus 2k. This is the result.